If you have any questions, feel free to write in the chat and I'll take one by one. And I'll try to answer all the questions. And if any doubt which I cannot clear here, I can always write you back in our group. Okay. So I request if you have any questions, you just write in the chat box. There are a few questions was asked in the shared Excel sheet that I'll take a little bit later. So I'll just first open for questions who are here in live session. So you are requested to type your questions in the chat. Okay, maybe in the meantime, I can take questions from here. So there is a question from Chakali Sivalingamaya. Student question was, what are the career options with this course? So, so what I try to say is, this is a CVS VLSI design course, right? So you can write your specification in the higher level of specification. And in recent times, it's not only C, you can write your specification using Python as well as your ML application in TensorFlow or PyTorch. Even there are support for MATLAB. And so it's easy to write your specification for a big design at the higher level of abstraction. And this course will help you to understand how you can automatically generate a hardware out of this, right? So in a career sense, obviously, if you look into this VLSI industry, there are two kind of careers, right? One is basically expertise in the design. Design in the sense you are going to design a new kind of chip, right? So and many a time things start uh, very low when you write in the directly in RTL level, register transfer level design. But in recent trends, there is a huge focus on hardware accelerator design where we want to develop a specific specific chip from a specification which is written in higher abstraction level as soon as possible, right? And in such cases, most of the time specifications are available in the Python or C, C++. So in that sense, if you are looking for developing hardware accelerator from higher abstraction level, this course will help you to learn how you can do it very efficiently, right? So developing a hardware versus a efficient hardware is different, right? So you can always develop a hardware, but that may not be that may be very slow, or that may be taking a lot of area in your FPGA board. So knowing how to make it very fast in the sense it can run in higher clock or it take less area in the FPGA board is important, and this course will help you to learn that things. On the other hand, I'll try to tell you another part of the VLSI industry where this whole VLSI design flow rely on some softwares, and those software called electronic design automation softwares, right? This course primarily looks for high-level synthesis, which is C to RTL. But as I speak about in the introductory classes, that you can also have EDA software for from RTL to gate level design, or from gate level to transistor level design, and then your placement, routing, and all those things, right? So there are a lot of softwares involved. There are another kind of softwares involved, which basically test whether your layout is correct or you test your chip is correct. There are softwares that help to verify things. Right? So there are many kind of softwares is needed. So and in the first part of this course where I talked about the algorithms behind this high level synthesis, so that will help you to understand what is the kind of algorithm running behind high level synthesis. At the latter part of the course, I'll also touch upon this logic synthesis and physical synthesis in this course. So that will kind of help you to understand what kind of algorithm running here and what kind of software you need to develop, right? So and that is a good career, I can tell you. And there are quite few software EDF software company are there like Synopsys, Cadence, Mentor Graphics, and so on. So there is another if you are a very good coder, in the sense you are coding efficiency in C, C++, and you know what is the inherent algorithm running in these tools, there is a good career opportunity as well as in the EDA software companies as well. So just to conclude, career opportunity in the sense you have career both in the design side as well as you have career in the EDA software development. Okay. So there are some live questions. I'll take. Soham has some questions. Clock signal is not given mentioned in C++. So how to determine the behavior in the output? Yeah, it's a good question. And that's the kind of advantage this high level synthesis tool gives you, right? In the sense, so it's easy to develop your C++ code because you don't have any clock, any reset, there is no synchronous and nothing, right? But if you're developing your specification in C++, yeah, there is no clock. I agree. But finally, when you targeting your particular design for a bigger system, you should know what is your target clock, right? Uh, so you must be aware in a system when you where your particular IP that you're developing through high level synthesis is going to fit in, and there should be some target clock or minimum clock should be like this, right? And it's not only clock, there is a latency involved also in the sense that if this particular block that you're developing is fit into a bigger system, you must aware that when the inputs are coming and when the block that is actually connected later, when how frequently the output has to be passed there, right? That means the block that is placed after that, it may not expect output in every clock, or maybe it may expect the output in every say 10th clock. That means your latencies of the circuit should be 10, right? So those are the specifications that must be given, although your specification written in C, but those specifications will be given when you try to develop a system. And you have to make sure that the design that you're creating is achieving that clock. So that's the point I try to make it here, that although your C++ has no clock, but suppose you're targeting 100 megahertz, and then you figure out that whatever the RTL you are generating, the clock that you are achieving is say 200 megahertz. It's slower, right? Half of the speed that you're expecting. So then you should know what kind of optimizations you can apply within high level synthesis so that your design clock period can improve, right? So there are the technique I'll cover in the latter part of the course. So you should apply those kind of optimization within high level synthesis and re-synthesize the design to get another RTL, which the clock period is much faster than the other, right? So these are the tricks you should know, but but you have to apply those techniques in high level synthesis to get your RTL, which is kind of meets your target clock period. Okay. So next question again from Sachin is, can you please explain the use of Vivado HLS, when to use it in design and use it to a IP course in Vivado? Yeah, so if I understand your question correctly, so this Vivado HLS is primarily used for developing RTL from C++ code. Right? So we have now this tool is renamed as VTIS, right? And it has AI version and ML version as well. So inside this particular product, they have some already some IP is available. And if you try to develop your IP for say ML applications, then you can actually use VVT's ML and AI versions where there are already some inbuilt IP which will be utilized, and so that the RTL that will be generated is much efficient, right? So so in general, if it is not ML AI applications, say for image processing or cryptographic applications, specifically some data intensive applications, you can use, and if your specification is written in C++, you can always use high level synthesis to generate an RTL. Right? So that's the answer to your questions. And I can tell you with confidence that most of the companies in VLSI, they use Vivado HLS to not only Vivado HLS, there are some other HLS tool as well. For example, there is Catapult from Mentor Graphics. There are other tools as well. So they use high level synthesis tool to develop IPs quickly from Vivado specification. Uh, so there is another question from Kuruba Vinay Kumar. Question is, why still industry recruiting RTL design in India instead of using high level synthesis? Yeah, it's a good question. So, but I can tell you that an RTL HLS is still not cannot replace an expert RTL designer, in the sense that there are so many complex things that cannot be automated, right? Purpose of HLS is to expedite the process. So it's kind of a current, it's a kind of a which will replace the RTL engineer as you ask the questions correctly, but not for all applications people use HLS tool. Say for example, in some cases where your say target clock is not that critical. In such cases, you use viewer HLS or any other HLS tool. But in some cases where say your clock is very critical and you with automation you're not able to meet it, right? I'll tell you certain examples. Say I'll take one example specifically. Say you have this array access, right? I'll take this example to tell you how this experts can beat HLS tool. So you think about this array access. When you write a program, you don't care about how many times the array is getting read, or a particular element of the array is getting read during C program. But you think about this when the array is getting mapped to this in the hardware, this array will be mapped to block time, and the block time has a very fixed number of port, 1 or 2. So now this array access is a constant. Right. So now you think about that you have written a very C code where you have no control about this, how many times you're reading, and most of the time you are actually reading the same element multiple times. So if you now use HLS, and it may generate a system where the number of clock cycle needed to get the output is much more because of this constant of the array access. On the other hand, expert, he knows that the data is there and he knows I'll read only once and I'll probably put that data in some register, I'm going to use it. So I'm not going to get constrained by the array access or the RAM access in the hardware. Rather, I just fetch the data and store locally, right? So it's kind of a buffer and I reuse locally. So this kind of strategy he can take directly, which not always possible by HLS tool. So to give your a precise answer to your questions, that we cannot always replace the RTL designer by HLS tool, but many cases HLS can replace the RTL designer where it is not the design targets are not that critical and your design you are actually in a hurry. That means your design time is fast, right? So in such cases, HLS is very useful. So next question. This is not a question. This is the first live session for CBS VLSI design. Yes, we'll have 2 more. Please feel free to ask questions here. And also, if you have any doubts later, you can always ask question in the forum, and we usually answer the questions within 24 hours. Praveen has a questions. When do you say operation A is going to be scheduled in the time step L? Does that mean positive edge of clock I? Or we have to specify such things explicitly in the tool? Yeah, you don't have to. So basically, this scheduling will be done by the high-level synthesis. So you have a specification written in C, and there are many operations, right? And there are maybe 20, 30 operations. And as I mentioned in the lecture, that you cannot execute all of them in one clock. You can, but your clock period will be very slow, or the number of resources will be too much. So what is the general strategy is followed in HLS is you try to schedule this operation over multiple clock, right? So you are not going to execute everything in one clock. Rather, you want to execute the things in say 10 clock or 20 clocks. So in such case, your schedule determine exactly which operation to be executed in which clock, right? So once you determine that, then you are going to happen this allocation binding and data path generation. But in harder, what is going to happen? So if I take your example, say operation A is scheduled in timestamp I, what is going to happen? So whenever the positive is come, so you know what is the control signal. So correspondingly, the data path will know what operation is going to be executed in the data path, and that is nothing but the operation corresponding to A. And it will happen. And whenever the next positive is come, the result will be updated in the destination register, right? So this is how the things will be executed in the hardware based on the schedule that is determined in the previously, right, in the high-level synthesis tool. So you don't need to talk about anything about tool, because when the Verilog will be generated, it will be specifically this normally HLS generated code has a single clock. So as a result, all registers will be synchronized and the whole thing will be happen automatically with the positive edge clock, right? There are some scenarios where the asynchronous design creation is possible. specifically in the data flow optimizations that I will cover in the later part of the course. So there is a question from Pratik. Pratik has a question: true random number generation, which part for use for synthesis design? So I don't understand your questions precisely. So I know there are that true random generator is a big problem in it's a good problem and interesting problem in RTL design. So if your question is how can you generate this true random? I mean, I don't know you unless your specification is written in higher abstraction level in C++, you cannot use this tool, right? So if your specification is in C++ or C, yes, Pratik, you can tell me.
Yeah, regarding sir, random number generation, I am asking so regarding FPGA. FPGA basically designed for synthesis and regarding the custom sim regarding two random number generation. I want to calculate a randomness. So randomness and of any random number will be designed in basically Vivado or basically custom sim mentor graphics, which is a general tool I am asking to that. For tool regarding the Vivado HLS tool will be used for that. Bit string generation, synthesis design, IP code generation, and pipelining as well as multiple.
Yes. So if your specification is in C++, you can always transfer it back to RTL and then you can map it to in a PGA board and see how it's performing.
Yeah,
so
sir,
it is possible.
RTL level, sir, RTL level generation basically Xilinx Xilinx Spartan 3 will be used for that. Basically evaluation of AIS 32 point something like board. Then I am asking for that, sir, in C based, so what is part of C based of that random number generation? How you can use it?
Yeah, understood. So it doesn't matter which board you use, right? So when you basically synthesize a design through HLS, you have to select a board, target board. And how does it matter the board? It matters about the size of the board and the kind of resource of the board. In FPGA board, the resource is fixed, right? So if the Spartan 3, the board you are specifying is a kind of a low cost board.
I am asking, so LUTs and number of CLB resources. So, sir,
Yes,
which
yes.
number of LUTs and number of CLB resources and tiles CMT will be used for that actually?
Yes, so in the board, so whatever the target you select based on that, the number of CLB, number of DSP, number of BRAM is be decided, right? So now if your design is very big, probably if a smaller board is not a good fit, right? You cannot fit a big design into a smaller board. So then you have to buy a bigger board. So that's the only thing. Otherwise, it's fine. So if your design is small, whether you take a big board or small board, it doesn't matter, right? Spartan 3 or Spartan 6, it doesn't matter, right? Only thing is that if I understand your question correctly, so as long as your specification of the random number generator is in high level behavior, I mean high level specification, you can always use Vivado HLS to map these things to RTL. So that means you can generate an equivalent RTL out of it, and then you can dump those RTL into a PGA board and you can test whatever you want to do, right? So that's the answer from my side. Okay, so yeah,
Regarding static time analysis, sir, in Vivado HLS used or Questa sim meta graphics?
Questa. So HLS does not do any static time analysis. So for that you have to use Questa or any other tool. Yeah, you are right. But Vivado is only a synthesis tool that will convert a C code into RTL, a very long. That's all. It don't do any other analysis. It has simulation specific simulation support. That means the generated RTL is correct or not. It has RTL simulator. So you can at least simulate your design with some inputs just to check whether your Verilog is correct or not. But it does not have any static analysis. You are right.
Sir, hello. Sir, clock tree synthesis and floor planning will be Questa sim or meta Vivado HLS used?
Vivado, so that HLS would not do this floor planning on. It has ISC tool, right? So it has the logic synthesis part that you can utilize. So whenever you buy a board, all tools are available with you, right? So you can utilize Xilinx ISC tool, system design tool that will map your RTL into a FPGA board automatically. It will generate the bit stream. So you don't need to. So for FPGA target, you cannot use the synthesis tool that's targeting ASIC, right? So you have to use Xilinx flow to get it dumped into a Xilinx board.
Okay, so clock tree synthesis and clock tree generation will be used Xilinx ISC 9.2.
Yes, so in FPGA board, as far my I understand, so this is specifically this clock resynthesis and those things are important for ASIC target. Because that time there may be a lot of glitches happen, right? Because if your clock is not properly connected, there will be a lot of glitch. But in FPGA board, it doesn't matter actually. So primarily the problem statement for this is you have this Verilog code. Can you how many CLB you need to store this, map these things, and how do you put the multiplier into the DSP? How do you put your RAM into this block RAM? Those are the problem it usually the ISC solves. I mean, as far I understand. Clock pre-synthesis, I
The
think it's
placement
not
and
that.
routing part. It's a placement and routing part will be used Xilinx ISC, I think, not
Yes,
Vivado
yes.
SLS.
No, Vivado is a higher level, I mean, high level synthesis tool, right? So
Okay.
once you get the RTL from Vivado, that you can use in Xilinx ISC to get your
Sir,
floor plan.
Xilinx ISC, sir, next question. Xilinx ISC C based and C++ will be used both with Xilinx ISC 9.2.
There are two tools, right? The Vivado HLS, which will take C and it will give you a Verilog RTL. Then you have an ISC tool which take that Verilog and generate the bit stream, which can be put into an FPGA. So it's a kind of a flow. Okay.
Okay.
Okay. Thank you. So next question again from Sachin. Looks like Sachin is very active. So I have one more question. Bitstream is generated using Vivado HLS tool after design. Then I have found a few applications. They use Xilinx SDK even after generating the bitstream, and I think yeah. So basically, the complete flow is like high-level synthesis, then logic synthesis, and then physical synthesis. So there are three set of tools. And there are other tools that like SDK or other tool where you try to develop a system. In the system design, in this that you develop one IP through Vivado and say, oh, there are already some IP available, right? So there may be some IP already available with you, or you bought it from third party, and then you want to integrate them together to design a system. So it is also possible, right? So there are other tool this Xilinx provides which help you to develop a system. So typically HLS will help you to develop a particular IP, but integrating multiple IP, you need other tools. And just one IP you want to dump into FPGA, the flow is like you use Vivado HLS, then Xilinx ISC, it will give you the bit stream and you can map it to FPGA and test, right? But developing a system, you need other tools as well. So Viva Singh asks question, is FPGA part of VLSI? Yes, so nowadays FPGA is integral part of VLSI in the sense, yeah, although see what are the things you can develop your application specific chip, which is called ASIC, application specific IC. So which is basically a very processor, you kind of developing a processor or a chip which is performing exactly what you want to do, right? And there is a general purpose processor where you can map any application, you can run any application, right? So in the general purpose processor, what you have basically set of instruction, right? So it's a very complex system, and you can run. It has set of instructions, and if you have a compiler which can map your application into those set of instructions, then that particular process can run your application, right? So as simple as that. On the other hand, in ASIC is basically a application specific chip where you finally develop a chip which is going to do only your application, nothing else. It cannot run anything else. What is FPGA? It's FPGA is kind of a reconfigurable, right? So field programmer will get it. It's basically even if you develop a ASIC chip, but you want to test it, right? Whether you want to just think about a processor, it's a Verilog code, right? Verilog or VSDL code. You think about an Intel processor or AMD processor. So when they develop, it's a Verilog code and they want to test it, and it has million line of Verilog code. It is very difficult to check whether your Verilog code is correct or not. What they do, they basically uh, put those whole processor code into an FPGA, because FPGA is a reconfigurable and you can map any hardware HDL code into that, right? So you use Xilinx flow and dump that whole processor code into the FPGA. So now you think about your desktop, you have a desktop, you have a monitor. The only thing is that you don't have the desktop and there is a FPGA board, right? So there are maybe one FPGA board may not be enough. There will be 4 or 5 FPGA board connected together and your processor is running there. And how they test, they basically run everything from their desktop, use keyboard, mouse, and and the processor is running in FPGA board, and it's called emulation, right? So basically, and they run it for, say, they run the various applications. They put so they try to put a lot of OS on top of that, and they use it, right? So this is also possible. So what I'm trying to say is that FPGA is not something is deassociate from VLSI. In the VLSI flow, this FPGA is uh, used primarily for this kind of testing. You dump your Verilog code and see whether it is functionally correct or not. On the other hand, in certain applications where it's not a mass production, right? You don't need to create 1 million chip. But suppose you develop a chip which will be put in a, say, some spaceship or something going into space. You need only a particular um, application to be run on that. So in that case, you may not want to develop a ASIC chip. You want to develop you want to create the system and you put it in a FPGA board and you put the FPGA board into the space, right? So that is also possible. So in some cases where the number of production is less, right? So it's not a million chips. You can actually sell a FPGA as a product, right? So how do you run your system in that? But primarily FPGA is getting used for verification, right? So you develop a big processor, but you want to make sure that there is no bug, and you basically dump that Verilog code into a FPGA board and you emulate, and it's kind of running as a dummy processor, right? And if you do not find any bug, that means your process is correct, and then you go for ASIC development, ASIC chip processor development, right? So it has a lot of use in VLSI. So it's not, it's always part of VLSI flow. So Proveen have one more question. The Verilog, we have freedom of specify passage or negate. Do you have such flexibility here? I think that much of his specific is not there. Either you have to use passage or negate. I have to see the detail specification. It depends on the tool. There may be some tool which may have advantage. To be honest, can you explain me what is the advantage of negate, using negate over passage? I mean, I don't know. But usually those kind of flexibility is limited in HLS2. Next question from this Soham again, that if possible, please cover the trick or method for clock. Yes, this is already covered. So this course is nicely structured. If you look into the course structure, the first half is the background theory, all the algorithms. Second half is the tricks. So in the second half, I have talked about many interesting things like how do you write your C code, which is hardware friendly, right? So hardware efficient C code that I have talked about. And what are the optimizations available in the high level synthesis and tool, and how to use them usefully, I mean, efficiently. So those are the things I have covered in the next second part of the course. So please follow the course. You'll get all the answer you have. Okay. So are programmable and reconfigurable are same. Uh, Programmable and yeah, it's kind of the same because you're going to reuse, right? So you have, so what is there in FPGA? FPGA board has, if you look into this, it has CLB, right? CLB is what? It is nothing but a table, right? It's a ROM, it's a memory. I'd say if say there are 4 input, 1 output CLB or LUT, it has basically, it can take 4 input and 1 output. You think about there is an AND gate file that is a 4 input and 1 output, right? Or you can think about a design which may have 100 of gates, but it has, they are connected, interconnected, but it has 4 inputs and 1 output, right? So as long as you can take a sub circuit which has 4 input and 1 output, you can identify what is the input output relation, that if your input is 0 0 0 0, what is the output, what is 0 0 0 1, what is the output, and so on. So you have that 16 possible value because there are 4 bits. You dump that data into that table. That's all, right? You don't need to put this all the gates there physically because it's nothing but the behavior of 4 input, 1 output, right? So that you just identify and you put that in the table in that ROM inside the LUT. So LUT has that. So once you try to map your behavior into FPGA, you try to identify if your say LUT size is 4:1. I'm just taking an example. There can be 2:1 or 8:1, 6:1. It depends on the architecture. But the problem is you see your gate level design, you identify a sub-circuit which has 4 input, 1 output. You identify what is the input output correlation, identify and put that value in the table. And when it will run in the FPGA board, what is going to do? You just see what is the value is coming input output. It will read that data and give you the output. So that's all. Similarly, if you have a say multiplier, you put it into DSP. If you have a RAM, you put it into block RAM, right? So once you do this, so your behavior is already dumped into a FPGA board. And what is remaining is the interconnections. And this interconnections is also reconfigured. You can think about you have there are a lot of wire between in the x-axis. So so they are parallel to and there are a lot of wires in the y-axis, and every crossing there is a switch. And if you want to put the data from that line to this line, this switch will be one, right? So once you map these whole connections into FPGA board, I have told you that how logic gate is getting mapped. And in addition, based on the interconnection, this switch will get 1 or 0, right? So that is the configuration. So once you set this, your design is nothing is mapped to FPGA board, right? That's all. And now if you want to reconfigure that you want to map another design, what you do for that particular design, you again decide what is the LUT value, what is the interconnections value, and that's all. That's how you can put any design into FPGA board, right? Pratik has another question in Verilog syntax test bench code, how to write, implement, simulate. I don't understand your question very clearly. Yeah, so in Verilog you can write test bench, right? So you can think about your test bench is nothing but if you just see in context of C, if you have a function, you think about your main is the test bench, right? So in the main, and the main function that you want to develop, right? Say you want to develop FFT. So FFT is a function call. So that in the hardware that FFT will be a module in Verilog, right? And what this main function does, it basically in every it gives one possible input to the FFT. It executes and the output comes. It just cross check whether the output is correct or not, and then it gives the next set of input, right? This is how the whole the test bench writing things works in Verilog in high level. So one question is, please put this video on NPTEL course. I request this coordinator to put it. I hope it will be available live. Okay. Yeah. Pratik, in HDL or FSM implementation, okay. In behavioral and data flow blocking and non-blocking assignments, blocking use. Yeah, so in behavioral and data flow, blocking and non-blocking assignments, block use as sequence and combination, how differentiate and use in modeling with reg and wire. See, I mean, you need to understand the Verilog syntax, and which is not part of this course. Very honestly, I never explain how to write those things in this course. But if you are interested, you can just take some Verilog lecture provided in NPTEL. I know that there is one very good NPTEL course on Verilog design. So you can just go through it to understand those things. Okay. Okay. So in the forum, there are one more questions was asked by Sachin Devendra. The question was, I am working on speech keyword recognition using Zaibu board. I basically refer tutorial of IP block and IP block design connections with Zing processor. I refer code and modified it. Further make IP of voice recognition. Basically, I have doubt in block connections. Honestly, I'm not expert of that part. I'll request you to take I mean, definitely this Zeng processor associate software can help you. So my only suggestion will be you should understand what kind of connections it provides, whether it's a JTAG or any other PCI or any other kind of connections it provides. So and the tool must have some option to that. To be honest, I'm not the right person to answer this question here. Okay, so I think I'm done with all the questions, and thank you everyone. It's a very nice live session. I like it because there are so many questions coming from you, which I really like. And I hope this course will be useful for you in your career. And please feel free to post your questions in our forum. We'll be happy to answer all the questions here. Okay. So maybe I'll wait for another couple of minutes, see if any further questions.
Hello, sir.
Yeah, Pratik. Yeah, please
Yes,
tell me.
yes, area, power, dissipation, and throughput. There are some parameter will be, sir, generated basically initial checks as well as any import designing, study time analysis. So, sir, how will be, sir, calculation these parameter based upon if conventional systems and non-conventional previous systems will be existing works will be used at as a latency problems, skew, and then this type of, sir, basically parameter will be report timing analysis, hold report and timing analysis, and something like LUT's
Yeah,
report
so
checking.
yeah, so in Vivado HLS or any other HLS tool, they give your estimation. Okay, so what is the overall? If you try to map it into FPGA, how many LUT it will need or how many block RAM is need. Similarly, the overall power in the sense that what will be the approximate value. Similarly, the latency as well as the achievable clock period. So
Hello.
you understand.
Sir,
So this
throughput,
kind.
sir, I am asking, sir, throughput will be check will be basically how you check in the throughput in hold and starting time analysis will be said that.
Yeah, so only thing I can answer here is that this HLS tool give all the estimations. Okay, if you look into the report, I'll request you to use Vivado HLS and run in and see the synthesis report. And it give you all these things. So what is the throughput, what is the latency, and what is the target clock period and all. But understand that this is very high level, right? So it is kind of an estimate. Sometime it may have 10%, 20% deviation from the approximation or the estimation that these tools HLS tool provide, right? So if you are a hardcore RTL engineer, so in that sense, you can actually guess from those number that HLS tool provide, and then you can actually, if you feel that that may create some problem in the static timing analysis, you probably have to resynthesize the design, taking some measures, right? So now it's a good area you can think about that in RTL level. Say suppose your the questions like the throughput. Throughput I understood, so you can actually improve throughput, and there are techniques in HLS which can improve throughput. But say you have some timing violation, right? So some glitches is coming. So, and uh, that's something, how can you take care in HLS? So suppose you found that because of this structure of the data path, there is a mismatch in the data. Some data is coming early, some is coming later, or say clock is not reaching here. So something like this. So that can be an interesting HLS area that now you come back and you add certain constant in HLS so that it understands that, oh, I have to do it in different way. I cannot do it this way. And then it can generate another variable of which you will meet your target thing. So far, honestly, this tool may not able to do it. Maybe you need further research on this domain, that you find out some timing violation in your latter phase of your design, and then you come back in HLS and you tell HLS you don't do these things, such that your timing violation won't come again, right? So that can be a good research problem, to be honest. But as far as I understand, not much work is there in that sense. Okay,
Hello.
yeah, Pratik,
Yes, sir.
please go ahead.
IO planning and IO resources at which step will be used, sir? After that, bit string generation and synthesis. Before that, basically IO planning will be used for static design. Import.
FPGA, yeah, FPGA flow, I think it will be automatically taken care. So as long as the FPGA board has enough IO port, and then your design will can be mapped there. Otherwise, it will say you have the number of requirement is too much, right? So when you do HLS, so what are the IO will be generated? It depends on your function, whatever the function you're going to synthesize. Now you think about the function has array as the argument, right? And there are so many, you can think about that if the number of port will be generated, finally the IP that you're developing through HLS, it depends on the number of argument in your function. So, and if you feel that, and once you get the RTL, you can't change it, right? HLS already fixed how many number of ports you need. And in the target architecture and the FPGA board, if those many ports are there, it will automatically getting mapped. You don't have to bother about anything. But if the number of say IO port is very limited because you're using a very small board. In that sense, you need to redesign your C specification so that the number of IO is less. In some cases, you can make some of them as global, or some cases probably you don't need that. You can club certain input together. Even there are some techniques through which you can reduce the number of IO. But as long as to answer your question, if you use HLS to develop things, HLS determine number of IO ports, and if your FPGA board does not have that many IO ports, then this map that RTL cannot be mapped to that particular board. You need a bigger board, right? And sometime you can actually modify your C specification so that the IO port reduce, and then you can actually map it to that. Okay, so that's the precise answer from my side. Okay, so I'll wait for a couple of minutes, maybe till 5, yeah, to answer if you have any questions. Otherwise, I will conclude at 5. But I'm very much happy from you people that you are have following my course with interest.
Hello.
And yes.
The meta stability basically problems are regarding setup time and hold time.
Yes.
Basically, meta stability condition basically in a clock optimization basically as a part of the meta.
Yes. Yeah. So
Meta
basically,
stability of
yes.
probability of meta stability will be how much probability of meta stability generation.
So HLS does not take care of those things. I can tell you. Only thing is that see if your target clock is say 10 nanosecond and your data is generating in say 9.999 time. So that means your path is critical path is too big. In that case, you may have so that there is no enough hold time, right? So when the clock period come, there should be some buffer time where the data will get stabilized in the register, right? So if in such cases happen, then you might have a RTL that is designed through a high level synthesis which have the meta stability. And specifically, if you are creating two data path, to a register where there is two path, which is one is very long and another is very short, so that time there is some glitch usually comes, right? So those are the kind of problem, but I don't think HLS is smart enough to handle those things directly, right? Unless and until you take specific care. Okay, so any recommended books? I follow the books of Demetrius. I think I have specified in the web course website. So that is a very good book for the underlying theory. Okay. And for the application part, the second part of the course, there is no book, very honestly. So what I do usually, I follow the user manual of Vivado HLS, where all these uh, optimizations that is available in the tool is mentioned and their usage is mentioned. So I do follow that user manual and I also request you to do that. And there are many other things I have covered in the course, like how to verify the high level synthesis tool, or say how do you make the RTL that is designed to high level synthesis secure, or say how do you basically make sure that there is okay. So yeah. So and so you try to make a secure design through RTL that I have already covered. So those kind of things, there is no book. So you have to follow certain paper, and usually I refer those paper name in the video lecture itself. If you have uh, have any problem, any topic, you can always put the question in forum. I will give you the proper reference. Okay, so I'll just tell you the book name here. Just a second, I'll type and find it out. So I'll recommend to follow this book. This is a very good book for. So this is the book I was talking about. A good book, and it has Indian version, so 300-400 rupees will get the book. There is one more very good book in this area, which if you're really interested in high level synthesis, So you can actually see this book. This is a very good book. I recently find it out. So this book is also, and again, the soft copy available in internet. So this is also another very good book. So this book is talking about, so given a C program, so suppose you have a merge sort program, which you try to map into FPGA and you're seeing that it's not good, right? So how you want to make it very fast merge sort. How can you do it, right? So so this is another good book where they talked about take various applications, and then so how can we modify this input C code, or what kind of optimization you apply to make the generator efficient harder. So this second book is really good, and the first book is for the theory. And other paper, I'll suggest, if you have any particular topic you do not understand and you want to study the original paper, you please do post in the forum. I'll send you the link. So here giving the all link is difficult because I mean it is I don't know which lecture is covered what, right? So there are 40 odd lectures. So if you need a specific particular lecture corresponding resource, you please post in the forum. I'll provide you the corresponding paper link. Okay. So yeah, so I think yes.
Hello. Concept of jitter will be, sir, in clock generation will be explained, sir. Concept of jitter.
I don't know, to be honest. I know this glitch. I know this metastability and clock synchronization. So I think jitter. I mean, to be honest, I should not answer. There may be when you have multiple clocks. Between two clocks, sometime you have to pass on data from one clock domain to another clock domain. So clock domain crossing is another challenging problem. So when very honestly, I'm not a RTL designer. I'm a computer science engineer, so I know the automation part well, but I do know the concepts in high level. So I mean, I'll request you to go through the proper resource for that. I may not be the right person to answer this question. Okay, so thank you everyone. I hope you will continue this course and learn a lot of things, and come back in the next live session, which is scheduled in the next month. Thank you all.